All right, this is chapter 3, lesson 3.5. We are going to be working with sets. Okay, so to write sets and identify subsets and to find the complement of a set are objectives for this lesson. Okay, we're going to go over exactly what a set is and we're going to go over what a subset is as well. Okay, all right, so a set. Okay, a set is just like any set of numbers. It's kind of like, and you group them with this bracket looking thing. So it looks like this. We're going to call that a bracket. Okay, and everything inside your bracket is considered your set. So in roster form, that's where you're just listing out all of the numbers. So like 2, 4, 6, 8, any multiple of 2, the even numbers. You could label this anyway. So the set includes all even numbers. Greater than 0. Okay. What's called set builder form is you identify a variable. So our first part of set builder form is x, right? And then next to it is this little line. So it's like x, then there's this line, and it says x is a multiple of 2. So x could be any multiple of 2, right? So like 1 times 2 is 2, 2 times 2 is 4, just like all the even numbers, right? So that second part, this second statement, is everything that x could be. So you'll see it where it's going to be like x greater than 9, x less than 6. It's whatever stipulation occurs so that we have to write it as a set, okay? Now, this is just an example. This isn't like x greater than 9 is not what we're setting up here, okay? And we are going to do some practice with this. So, problem number 1, using roster form and set builder notation. How do you write T is the set of natural numbers that are less than 6 in roster form? Remember, natural numbers are the ones like 0, 1, 2, 3, 4, 5, 6, all those nice ones, okay? So, in our natural numbers that are less than 6, roster form, here we go. Well, 1 is the first natural number. 2, 3 is less than 6. 4 is less than 6. 5 is less than 6. Is 6 less than 6? No. So that's where we're going to stop. So this is our roster form of our set. It's 1, 2, 3, 4, 5. So we have 5 numbers in our set. In set builder form, okay, you would assign a variable, right? So let's say T. T is our set. So T technically equals this set. So we're going to say T equals, let's assign a variable lowercase t. You can, a lot of times you're going to reference this line as such that. So we have a set with T such that T is a natural number less than 6. Okay? Another way you could have written it is like T is a natural number and then had another stipulation. So I'm going to write another way we could write this set. Let's say we had T such that T is a natural number. Okay, I'm going to put NAT number. And then I put a comma, T less than 6. Okay? So whenever there's a comma, that's just like adding another stipulation. It's adding another condition for the set. Okay? All right, so let's try an inequality with set builder notation. So in set builder notation, how do you write the solutions of negative 5x plus 7 is less than or equal to 17? Well, first off, people, we need to get this inequality simplified. So this is going to be negative 5x. We're going to subtract 7 from both sides. That way now we have less than or equal to 10. We divide by negative 5. Divide by negative 5. Guys, we divided by a negative number. The first thing we should have done is flip our inequality. Remember? Okay? So we're only left with x now on the left side. And it's going to be greater than or equal to negative 2. Because 10 divided by negative 5 is negative 2. So this is what we've got, right? Before we were just solving the inequality. So we were just coming up with x is greater than or equal to negative 5, right? So x could be any number greater than or equal to negative 2. Why do I keep saying negative 5? Negative 2, okay? So it could be 1, it could be 0, it could be negative 1, it could be negative 2, but any number bigger than negative 2. And we want to write these solutions in set builder notation. So we're going to write a set or a bracket, and we've already got our variable listed. So we're going to just put x. And x is such that x has to be greater than or equal to negative 2. And it's that simple, guys, okay? The only difference here is that you're adding these brackets, and you're also adding that you're identifying the variable, okay? So you have to introduce the variable in the set, and that's where we put the x. And then this is just saying such that, and then you give the condition. So x has to be greater than or equal to negative 2. X just can't be anything, right? It has to be greater than or equal to negative 2. All right? Okay. We're going to try one more, the same exact thing. So we're going to solve this inequality, and then we're going to go ahead and write it in set builder notation, okay? So let's go ahead and solve this. We've got 9 minus 4n is greater than 21. Guys, remember our variable here is the n, right? And we're trying to get rid of everything around the n, right? So we want to get rid of the 9 first. The 9 is important to get rid of because otherwise we would be dividing, and we don't want to divide 9 by 4, okay? That would just be kind of nasty. Okay, so we subtract 9 from both sides. We're left with negative 4n on the left is greater than 21 minus 9 is going to give us 12. Now we're going to divide by negative 4. Divide by negative 4. The reason we're dividing by negative 4 is so we can get n to be positive and by itself. But did we just divide by a negative number? We sure did. Remember, multiplying or dividing by a negative, you're going to flip the way your inequality is facing. So now n, instead of being greater than, is now going to be less than negative 3. Okay? Now, we've just solved our inequality, but remember, we're trying to write it in set builder notation. So we're adding an extra step. Let's put our brackets. Our variable is n, and n is such that n has to be less than negative 3. Okay? You guys, I like this lesson because I think it's super fancy. Like, look how fancy that looks. Like, it's pretty cool. So, n has to be anything less than negative 3. It could be negative 11, negative 12, negative 13, but it's got to be less than negative 3. Could it be negative 3? No. Why? Because it's not less than or equal to. It has to be less than. Okay. All right, subsets. So, there's a little picture here, right? So I want you guys to circle the A and write that this is a set, okay? B here, our nice little B in green, represents a subset, okay? So a subset is completely included inside of a set. So subsets are completely included inside of a set. Okay, so you notice how B has no portion that's outside of the original set A. That is what we're talking about, people. Okay, so B is completely included inside of our general set. Our subset wouldn't be completely included in the set. it would include a number that's outside of set A. Therefore, it wouldn't even be a subset, okay? Okay. Now we've got to find our subsets. So what are the subsets of the set 3, 4, 5? All right. So first off, let's start small. So let's start with there is a set that includes nothing. Fancy, right? So it's just literally 2 brackets with nothing in it. There's also a notation for it where you just draw a circle and put like a side, like a diagonal line through it. This is an empty set. Okay? So it includes nothing. It's just like air, space, nothing. Okay? Now, the empty set is a subset of all of other sets. Okay? So the empty set is a subset of all other sets. Okay? So what are the subsets of the subset or of the set 3, 4, 5? The empty set includes that. Okay? Now, let's do another set. Let's start with stuff that includes one number. So 3 would be a set that's or 3 would be a subset that's included in our regular set. We could have 4, and we could also have 5. Okay? Let's try with 2 numbers now. So let's take the set 3, 4. There's also the set, oops, gotta draw my brackets, 4, 5. And then lastly, there's the set 3, 5. Okay? And lastly, the same set 3, 4, 5 is actually a subset of itself. Okay? So anytime it's asking for a subset, you can always use the original set. So 3, 4, 5 is a subset of 3, 4, 5. Why? Because it's completely included. Now, the reason no other sets can be included, because they would have to include another number, right? They wouldn't just be 3, 4, and 5. And therefore, if we look back, so these are all of the subsets of our set 3, 4, 5. Okay, we're going to do one more. What are the subsets of the set P equals AB? Okay, now let's start first off with the empty set. So we draw nothing, okay? Or we could have drawn just this fancy circle with a slash through it. So this is the empty set. So there's 1. Let's start with our single number one. So A could be a subset of AB, and also B could be a subset of AB. And then lastly, we've got to include A, comma, B, the original subset, okay? Or the original set. So in this case, there were the empty set, A, B, and then AB combined. So there were 4 subsets. All right, and that's basically our lesson, guys. Let's check ourselves before we wreck ourselves. How do you write G is the set of odd natural numbers that are less than 18 in roster form? And then we've also got to write it in set builder notation. Okay, so remember, natural numbers start with 1 and they go all the way to infinity, but we want ours that are less than 18. So let's start with 1. Odd numbers, so 3 is our next one, 5, 7, 9, 11, 13, 15, and 17. We can't go any higher because 18 is the largest we can be. Okay, so that's roster form. Ayo. Okay, now let's do set builder form. Remember set builder form, let's go ahead and identify a variable. You guys love the variable x, so let's just use x, such that x is a natural number x is odd and x is less than 18. Okay? You can have more than one condition. You could have put x is an odd natural number less than 18, written it all out, all three of them in there, and that would have been fine too. Okay? But in this case, I divided all of my conditions into three separate kind of like statements, and I divided them with a comma. All right? So remember, set builder notation, you get a little funky, all right? In set builder notation, how do you write the solutions of 5 plus d is less than or equal to 8? So in this case, remember, d is our variable, so we want to get it by itself. So we're going to subtract 5 from both sides. And look how simple that becomes. That just becomes d is less than or equal to. 8 minus 5 just becomes 3. So we've got that. We can write that our... Ooh, that was a really bad one. There we go. In set builder notation, this is going to be, we're defining our variable d such that d must be less than or equal to 3. Okay? That is our set builder notation of that inequality. All right, what are the subsets of 4, 8, 12? Well, people, remember, what do we start with in terms of subsets? The empty subset, okay? There's also the subset of 4. There's the subset of 8. Oops. And then there's the subset of 12. There's the subset of 4 and 8. The subset of 8 and 12. And then there's the subset of 4 and 12. And then lastly, there's the subset of 4, 8, and 12. I know my brackets look really bad. Sorry. Actually, I really need to redo that one. There we go. And those of you that are like, I cannot write for the life of me that bracket symbol, you get better at it the more you do it. Trust me. I was in your shoes. Okay, so let's take a look at number 1. All right, we got the same thing for our roster form, so good. We got the same thing for G. See how they combined x is an odd natural number? We just separated both of them, okay? You can have as many conditions as you want for x, as long as it stays that it's the same, right? And then it said x is less than 18. We did that too. They defined in number 2, D, and they said D was less than or equal to 3. We absolutely did that too. And in number 3, they give all the subsets that we did. Absolutely right. Perfect. We crushed it. So, AO, we did not wreck ourselves today. Okay, on our exit ticket, is the first set in each pair a subset of the second set? And explain. A, the empty set, is that a subset of 1, 3, 5? Yes. Why? Empty set is a subset of all sets. So of course 1, 3, 5 has a subset of the empty set. What about, is 1, 3, 5 a subset of 1, 3? This one's no. Okay? You cannot have a subset that's bigger than the original set. Okay? So 1, 3, 5 is not, oops, that was interesting, is not completely contained in 1, 3. Because 1, 3 doesn't include 5 people, okay? What about the subset of 3 being a subset of 1, 3, 5? Yes. 3 belongs completely in the set 1, 3, 5. So, all right, here's your homework. Good luck.